So we've already started doing this method of problem solving that involves the factor label method. And we started doing this when we started looking at our conversions and conversion factors. So the factor label method is our problem solving procedure in which equations are set up so that unwanted units are going to cancel out and only the desired units remain. So we've already started talking about conversion factors being an expression of the numerical relationship between two units. So it's essentially setting the equation equal to 1, just like we did with our kilometers and our miles. So in our kilometer-mile example, we know that 1 kilometer has 0.6214 miles. So if we set this equal to 1, we can say 1 kilometer over 0.6214 miles equals 1. And again, that's because these distances are the same. If I walk 0.6214 miles, I've also walked 1 kilometer. And so our conversion factors, again, you can place them in either order. It doesn't matter because they're always going to equal 1 because they're the same value essentially. So you can put miles on the top or you can put kilometers on the top, and they both represent the same number. So this is our conversion factor. So if we have a sample or a starting quantity that's in miles and we want to figure out how many kilometers that is, we're going to use our conversion factor so that kilometers will be on top because that's what we want to get. Miles will be on the bottom. That's what we want to get rid of. And so when we find, we can cancel out the units that we don't want and we are left with the units that we do want. So we can find that 26.22 miles is equivalent to 42.20 kilometers. Also notice here the significant figures. The significant figures of the conversion factor do not count. This is an exact number, so you can ignore this. The only measured unit in this equation is your starting quantity. And so this quantity has 1, 2, 3, 4 significant figures. So you're going to need 4 significant figures in your answer as well. 1, 2, 3, 4. So it's useful when you're doing these types of problem solving to think through a rough estimate or work out a ballpark estimate to check your work. So we can see that kilometers are larger than miles, right? 1 is larger than 0.62. So if we're doing a conversion from miles to kilometers, we should note that the kilometers should be more. They're almost double. So we can ballpark estimate that our answer should almost be double of the 26.22, right? And so we get an answer that's much larger. It's 42.20. So this answer would check with our ballpark figure. So it makes sense that the number got larger. If the number got smaller over here, we would be like, what the heck? Kilometers are bigger than miles. Our answer should be bigger. And this would catch a mistake possibly. So if we put miles on the top and kilometers on the bottom by mistake, and we ended up getting miles squared over kilometers, that would be completely wrong. And that would give us a very wrong number. It would be a much smaller, weird number with weird units. So keeping the units and then also making an estimate or a ballpark figure of what our answer should look like will help us catch mistakes. So step 1, identify the information given, including the units, and write that down. So that's the first thing that you write down. Say, oh, I'm given 22.40 miles, or whatever the number is. Write that down. Step 2, identify the information that's needed in the answer, including units. They want us to find the kilometers that are present in that many miles. So we want our answer to be in kilometers, and you can write that down at the very end. And then you need to find the relationship between the known information and the unknown answer. How many kilometers are there in a mile? And then you plan your series of steps for getting from one to the other, and then solve your problem. Also remember to do your ballpark check. Make an estimate at the beginning and then check it against your final answer to be sure that the value and the units of your calculated answer are going to be reasonable. So here's an example of using this system to get the correct answer. A child is 21.5 inches long at birth. How long is this in centimeters? So we want to go from the English units into the metric units. So the first thing we note is that our starting is 21.5 inches. So we identify our given information and write that down. Step 2 is to identify the answer and the units. So we want the answer to be in centimeters. So we don't know what that's going to be, but it should end up being some number in centimeters. We then need to identify the conversion factor, and that's going to be held in your table. So this is the information that you would be given on the exam. This would be on your cheat sheet. You would be told somewhere in there that 1 inch equals 2.54 centimeters. We can rewrite that then in the form of a ratio. We could say 1 inch over 2.54 centimeters, or we could say 2.54 centimeters over 1 inch. In this case, we're going to want centimeters on the top because that's what we want to recover. We want inches on the bottom so that we can cancel them out. So we set up our equation with our starting information, 21.5 inches times 2.54 centimeters per inch, so inches is on the bottom, and we end up calculating our answer. The inches are going to cancel out, and we'll be left with our answer in centimeters. We can also see centimeters is bigger than inches, so our answer should be bigger when we calculate it out. So our ballpark estimate is that this should be a lot bigger, at least 2 times. And we can see that that is indeed the case, that we get a much larger answer. So this is close to our estimate. So our ballpark checks out, and 54.6 centimeters is a good answer for this response. The final thing that you need to check that's not listed on here is the number of significant figures. Again, your conversion factor does not matter. Your conversion factor is an exact reading, and so this one is not taken into account in the measured sample. The only measurement that was made was this measurement here. There's 3 significant figures in this measurement. We need 3 significant figures in our answer, and we have those.